Okay, so here we are, we're having a look at worksheet A to start off with. And question 1 says, consider the expressions. That's our expression there. And it says, list the terms in the expression. So remember, your terms are anything that's in between your plus and minus signs. So in this case, we have 4 of them. Okay, and our first one is 2p, comma, 3q, comma, 5r, comma, and 7. All right, so that's the answer for that one, 4 terms. State the coefficient of each pronumeral in the expression. All right, well, let's start off with for P, it is 2. For Q, it is 3. For R, it is 5. And then for 7 is a constant term, so it does not have a coefficient, nor does it have a pronumeral, so we don't need to worry about that one. What is the constant term? Well, we just talked about that. The constant term is 7. Okay, let's have a look at question 2. Write an expression for each of the following without using the times or divided by symbols. So A is halved and then 9 is added. So half of A, we go A divided by 2. Because if we want to halve something, we divide it by 2. And then 9 is added. So then we plus 9. B, 4 less than triple the value of B. So we need to triple B, so we times B by 3, and then we need 4 less than that, so we take away 4. Okay. Question 2, 2 is added to C, then the result is multiplied by 7. Now here's where you need to be careful, because we know that 2 is added to C, all right, which gives us C plus 2, but we also need to make sure that if I just say times 2, order of operations would say that I need to do the 2 times 2 first. So we need to use brackets and put that multiplied by 2 on the outside. D. D is multiplied by 3, and then the result is divided by 8. So if we multiply D by 3, we need to put 3D, and then it is divided by 8. So we put in our vinculum and divide it by 8. The sum of 6 and 1/5 of E. The sum of 6 and 1/5 of E. So 1/5 of E is going to be E over 5. Alright, because that's E divided by 5. That'll give us 1/5 of E. And then we're adding them together. So 6 plus 1/5 of E. The product of F and G is subtracted from H. Product of F and G is subtracted from H. So we're going to have H minus FG, okay, because we're multiplying those two together. And that is that one. 3. If M equals 4 and N equals 5, find the value. So here we're doing substituting. So let's just rewrite them. So first one, 7 times M, which equals 4. Okay, it tells us there. Plus 3. Alright, 7 4s are 28, plus 3 equals 31. The next one, 14. Take away 10 divided by N, which is 5. Alright, 10 divided by 5 is 2. 14 take away 2 is 12. Next one, M times N. So that's 4 times 5 divided by 2 plus 3 multiply 5 take away 1. So 4 times 5 equals 20. 20 divided by 2 equals 10. Alright, 5 take away 1 is 4. 3 times 4, because remember, if a number is next to a bracket, it means times. 3 times 4 is 12, which means our answer is 22. Okay. The square root of 8m minus 7. So we need to do 8 times m equals 4. Take away 7, and we need to find the square root. So 8 times 4 is 32. 32 takes 7 is 25. Don't forget this step, because we still need to find the square root. Square root of 25 is 5. 5 times 5 equals 25. N squared, take away m squared, and then find the square root. So, we need 4 squared. Sorry. This is where it's important to make sure you're copying out right. So 5 squared, take away 4 squared. So 5 squared is 25. Take away 4 squared, which is 16, which gives us 9. And the square root of 9 is 3. Because 3 times 3 equals 9. Alright, this one we have 12 over m, which is 4, plus 5. So 12 divided by 4 equals 3. 3 plus 5 equals 8. And then it's all squared. So 8 times 8 equals 64. Alrighty. Question 4. Complete the following table. So here we need to substitute the value of x into this expression, and then give our answers. Don't know what's happened there to those things. There we go. So if x equals 0, so 3 times 0 equals 0, so that'll be 6. And we're going to go along each row first because it'll help us. So 3 times 1 equals 3, plus 6 equals 9. 3 times 2 equals 6, plus 6 equals 12. 3 times 3 is 9, which gives us 15. So this one's going up by 3 each time. Here, 3 times 0 plus 2 is 2. 3 times 1 is 5. 3 times 2 is 8. And 3 times 3 is 9 and 11. Okay, so once again, this one's going up by 3 each time too. Here, 3 times 0 plus 2, so 0 plus 2 is 2, okay? And then 3 times 2 equals 6. 3 is 9, 2, 4, 8, 12. And then 3 is 5 is 15. Okay, so here. Are any of the expressions equivalent? Well, yes, they are. For them to be equivalent, it means that they need to equal the same thing. And we can see that this one and this one are equivalent. So you just write those in. So 3x plus 6 and 3x plus 2. Okay, question 5. For each of the following, find the expression that is not equivalent. Okay, so it's given us a list of expressions here. Okay, and we need to find the ones that are not equivalent. Okay, my suggestion here is just give x a value. Say x equals 1. Okay, so in our first expression here, x plus 3, so 1 plus 3 is 4, plus 4 times 1, which is 4. So this expression here equals 8. Here, 5 plus 4x, which is 4, so 9. 9 take 3 equals 6 plus 1, so that equals 7. Let's just check that again. 4 times 1 equals 4. 9, 6, 7. Good. Here, so these two are different. We know that those two are different straight away. We need to check this one. 3 times 1 equals 3, so we'll just change that. 2 times 1 equals 2. 3 plus 3 is 6. Okay, so this one's 8, so now we need to check this one. So 2 times 1 equals 2, and 3 times 1 equals 3. So 4 plus 2 is 6, take away 1 is 5, plus 3 equals 8. So our odd one out is going to be this, and our question asks us, for each of the following expressions, find the one that is not equivalent. So this one, so our answer would be 5 plus 4x, take away 3 plus x. And the reason why that is not equivalent is because it does not equal the same as this expression, and this expression. those three expressions all equal the same thing, okay, which is 8. Let's have a look at the next one. Okay, so 5, and once again, I'm just giving x a value of 1 to make it easy. So 5 times 1 equals 5, 2 times 1 equals 2. 5 take away 5 is 0. Take away 2 is negative 2. Take away 2, negative 2, and I take away another 2 equals minus 4. Okay, 4x, so 4 times 1 is 4, and 1x is 1, so 4 take away 3 is minus 1. Take away 1 is minus 2. Take away 4 is minus 8. Check that again, minus 1, minus 2, sorry, made a mistake there, minus 6, 4, 3 is 1, 0, no, sorry, it's minus 4, because I have 4 here, I take away 3, so my answer is 1, then I take away another 1, so I get 0, then I take away 4, and I've got negative 4. So these two, the first two, are definitely equivalent. We're looking for the one that is not equivalent. So 2 times 1 is 2, and 1x is 1. So 2 take away 7 equals negative 5, plus 1 equals negative 4, which means that this is probably going to be our expression that is not equivalent. 3 times 1 is 3, 1 is 3, so 3 take away 2 is 1, take away 1 is 0, plus 5 is 5. So that is my expression that is not equivalent. I'll just write it out like that. Okay. Last one, simplify the following by collecting the like terms. So here we are collecting like terms. Very simple process. Okay, let's start with the A's. Alright, so we've got 3A and plus 2A, which means that when I put them together, I've got 5A, and then I'm left with a plus 4. Okay, this one here. Let's start with the B. So I've got 10B, a minus 5B, and a plus B. So if I've got 10 bananas, I take away 5, I've got 5 bananas left, and then I add 1 banana, it leaves me with 6 bananas. Here, let's start with the 6, so it's a constant term. There's one more constant term here, so I can put them together. 6 plus 2 is 8. Now I'll start with my C's. So I've got plus 9C and minus 4C. Once I put them together, I'm left with plus 5C. Because if I've got plus 9C and minus 4C, the difference there is plus 5C. Then I've got 1 7D, 1 minus 7D, and that stays the same. 8x minus 3x plus 2x. So if I've got 8x and I take away 3x, I've got 5x. Sorry, that's just the bell going. So 8x take away 3x is 5x, plus 5 is 7x. And I've got a plus 6y, so I've got 7y. Okay, and I'm just going to quickly write in the answers for these ones. Okay, last one here, so 15st minus 8st leaves us with 7st. We've got a plus 5s and plus 3s, which gives us, if we put them both together, if you've got 5 sandwiches and 3 sandwiches, you have 8 sandwiches. Then I've got a plus 4 and a minus 2t. I cannot put these two in with this one, okay? They are different things. That is different to these two, okay? That there is my answer for that one. And that's worksheet A. Okay, so we're looking at worksheet B now. And let's have a look at question 1. It says, write the following expressions without multiplication signs. So all we're doing is we're simplifying this so that we're removing the, let me just work out what's going on here. We're removing the multiplication signs. So basically we just multiply the numbers together. All right, so 5 times 4 is 20. And then all our letters come along for a ride in alphabetical order. Okay, same thing here, multiply your numbers together. 3 times 2 is 6, 6 times 6 is 36. And then your variables, your letters, go along for the ride. Okay, there are our two answers there. Write the following expression without a division sign. Simplify your answer if possible. So here, we put in our vinculum. So it's saying 2m minus 1 divided by 3, and 2m minus 1 is in brackets. Thankfully, that is what a vinculum does for us. Whatever's on the top we do first. Alright, so that's our answer there. Can that be simplified? No, it can't. Alright, same thing here. 5s over 6t. Really important here too, that the first one always goes on top and the second one always goes on the bottom. Alright. Next one, here. Can we simplify this one? No, we can't. 4a over 7ab. We can simplify this one. Alright, so we can get rid of the a's. Alright, so our answer would be 4 over 7b. Okay, and then the last one, 9x, y, z over 12x, z. Alright, and here we can simplify again. So I can get rid of my x's and my z's, which leaves me with 9y over 12, and I can simplify more because I can divide both 9 and 12 by 3. Okay, and 3 goes into 9 3 times, and it goes into 12 4 times. My y stays there, so I've got 3y over 4. Alright, so that's my simplified version of that. The expression 3 bracket n plus 5 can be written as n plus 5 plus n plus 5 plus n plus 5. Simplify this expression by collecting the like terms. So all I do is I collect the like terms. So I've got 1, 2, 3 n's plus 5, 10, 15. And what's really important to note here is what I've basically done is I've used the distributive law to expand my brackets. Okay, so it's been exactly the same. Using the same method, write this in full and simplify the result. So I'm just going to use the distributive law here. So I'm going to multiply everything on the inside by what's on the outside. So 2 times 3a is 6a plus 2 times 7b, which is 14b. Alright, so that's going to be my answer there for that one. Question 4, it asks us to use the distributive law, okay, to expand the following. So once again, multiply everything on the inside by what's on the outside. So 4 times x is 4x plus 4 times 8, which is 32. Here, 7 times y. Remember, our operation always stays the same. You just bring that down. 7 times 6 is 42. Here, 5 times 9 equals 45. Minus 5 times 3, which is 15z. And then here, remember, when we have a variable in it as well, all we need to do is multiply the numbers first. So 3 times 9 is 27. And then our letters, or our variables, come along for the ride in alphabetical order. So once again, 3 times 2 is 6, and then our variables come along for the ride. Question 5, consider the following rectangle. Write an expression that gives the perimeter of this rectangle. So if we're finding perimeter, what we do is we add up all the sides. Alright, so my expression would be 4a plus 4a plus 3b plus 3b. And here I could also put equals 8a plus 6b because I could simplify it. Alright, so either of those two would get you marks. Use your expression to find the perimeter if a equals 4 and b equals 7. So I'm going to use this one because it's shorter. So a equals 4, so that's 8 times 4, plus 6 times 7. Alright, and 8 times 4 equals 32. And 6 times 7 equals 42. Once I add them together, I get 74. So 74 is my answer. Write an expression that gives the area of this rectangle. So the area of a rectangle is length times width. So our length is 3b, and our width is 4a. Okay, so that would be my expression, except there's a multiplication sign there, so I need to simplify. So I need to multiply my numbers together. 3 times 4 is 12, and then my letters go for a ride. Alright, use your expression to find the area if a equals 2 and b equals 3. So here I go 12 times 2 times 3, because a equals 2, b equals 3. 12 times 2 is 24, and 24 times 3 is 72. So 72 there would be my answer. Question 6. In Australian rules football, a goal is worth 6 points and a behind is worth 1. This means that the score for a team is 6G plus B if G goals and B behinds are scored. What are the values of G and B for a team that has scored 5 goals and 2 behinds? So all we do is substitute. Alright, so it's saying that G in this instance is worth 5. So 6 times 5, we're just using this expression up here, plus 2 behinds. So instead of it being just B, we make it 2. Alright, so 6 times 5 is 30, plus the 2 is 32. Next one. What is the score for a team that has scored 9 goals and 8 behinds? So once again, we write 6 times G, in this instance, equals 9, plus B, which in this instance equals 8. 6 times 9 is 54, plus 8 is 62. Alright? If a team has a score of 37, this could be because G equals 4 and B equals 13. Find 2 other possible values of G and B. Alright, so here you need to find 2 possible values where it will equal 37. Probably this one's not too hard because I'm just going to use a multiple of 6 to get as close to 37 as I can. So the one that I can think of is 6. 6 times 6. So if G equals 6, my expression is 6 times 6 plus 1 will equal 37. So 6G plus B, okay, will give me 37. Sorry. And in this instance, G would equal 6 and B would equal 1. Okay, so that's one there for me to use. The second one that I can use is if goals equals 5, it will make 5 times 6, which is 30. And then if my behinds are 7, okay, that's going to give me 37. So they would be my 2 values, or they could be 2 of the 2 values that you could use to find that answer. But really, there are multiple values that you could use in this instance to find the answer. So there's lots of correct answers there for that one. An electrician charges a $30 call-out fee and $80 per hour. Complete the following table. So here's our cost. So he charges $30 just to turn up, all right? But you only have to pay that once, and then he charges you $80 per hour, okay? So for the first one, it's going to cost you $30 plus 80, all right? Which equals 110. For the second hour, it's going to cost you $30 plus 2 times 80. All right, so that's, what's that, 160, 190. And then it's going to go up by 80 each time. So the difference between 1 and 2 is 80, and it'll be the difference for all of them. So we'll just skip ahead here. 270, 350, 430. So now we need to write an expression for the total cost if the electrician works for H hours. So our call-out fee is $30, and we add 80H, because 80 times the number of hours that he works. Use your expression to find how much it will cost for the electrician to work for 12 hours. So here we just substitute. So we go 30 plus 80. In this instance, H equals 12 times 12. Order of operations tells us to do that one first. Okay, 80 times 12 is 960. And we add them together and we get $990. And of course, you would put this answer in a sentence.